People often ask the question, is math invented or discovered? And I'd like to add my little something to that question, my little answer to that question, is that I think it's both. Hello, I'm Kieranlecam. This is me inside a hallway, and I'm going to talk to you about math.
Yes? 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 Yes! Oh, come on! Yes! Damn!
So, to start off, I'm not a mathematician. I'm not a physicist. So, if you feel like you need to officially be one of those things in order to think about the thing, you can feel free to walk away, because you'll always have that little voice in the back of your head going, well, he doesn't know what he's talking about anyway. I prefer to not have these people watch, because then there's no point. You're not learning, you're not listening. For those of you who are interested, please stick around. I'd like to talk about mathematics and my idea of what math is, where it came from, and why I think that the world of math has taken a bad turn. Now, I imagine that mathematics was created in some very simple way. Something like you looked at the world and you saw a stone, and then you saw another stone. And then a bit later, you saw a stone, and then you saw another stone, and then you saw another stone. And you thought to yourself, there's more stone than before. And so math was, in my opinion, because I'm not sure that we have any records of this, apart from probably etched on some cave wall somewhere, simply more or less. And that's it. But it's based on something. This, which is my key card to enter my room, because I live in a hostel. It's based on the idea of one thing, of a unit, what I like to call a unit. I just call it a unit. There might be another name, perhaps because I'm not studied in mathematics. There is a name for this unit. The prime something, I don't know. Obviously prime means something else, or probably not, but the idea of a unit, to me, is the missing ingredient with the more and the less. Now, you have identified that what there is more of is a unit. What there is less of is a unit. In the case of our caveman, it was stone. There was more stone. And you can then even create the noun, stone. And you can create a plural, stones. Now we've created language to describe this primal mathematical understanding that just simply comes from observation. Just you being a being, noticing a thing. And so it stands to reason that when you create the first mathematical notation, it probably was simply one. That's it. Just the idea of one. And then everything came from there. If you add one and one, you get something else. You can create another form of notation. A notation to mean an aggregation of these units. The specific aggregation of the unit 1 and 1 is 2. Then if you add more units, you create other notation, and then we create our counting system. 1, 2, 3, 4, 5, orders of magnitudes. We use base 10, right, which is counting 10 by 10, I suppose, like using the notation to reuse the same symbols every 10 figures, starting from 0, 0 being the first figure. Subtraction is the same, you just take away. Then multiplication is created. The idea that it's annoying to add all these ones like that in a row. Let's just sum it up to a number of times that we add a certain number. Same thing for division, the amount of times that you subtract a certain number. And so now we have our operators. We have the unit and operation. And of course, result. Eventually, we create the idea of a term, which is part of an equation. A thing and a thing is a thing. But always remember to come back to the original assumption, which was, well, we noticed a thing in the world. So we know that a term must remain a thing. A term, therefore, must be in existence. And existence means there, and it means positive. The mathematical description of a term must be positive. And so when you look back at everything that we've done, everything that you've heard online about negative numbers, about the world of imaginary, complex numbers, about all of these different types of numbers, all of this world was created sometimes at the expense of this fundamental notion, the notion that a number must remain in existence. So let's give an example. For instance, -1. -1, a negative number, in this case -1, is a problem because your number, and I'm not going to say your number doesn't exist, I'm going to say your number can exist only if you attribute it an operational power, operative power, the power to subtract itself to another number, but only when you've added it, I guess in this case, to this other number, when you've factored it in to this other number. So this makes us think, does -1 really exist in the same way as +1, as 1? No, it can't. What you've done is you haven't created a barrier called 0 and then just simply counted backwards. You've given in operational terms, because we use numbers to operate. We don't just line them up for no reason. We use number in math to operate. Remember the stones, more and less. We were in our minds operating already. We noticed it visually, but what we really did was notice 1, then notice 1, then notice 1. That means 1, then plus 1, then plus 1. And so we were operating when we were noticing these numbers. They didn't just exist on a piece of paper all lined up. And so you must operate on a number in order for it to be a number. So -1 has operative power inside it. Because when you operate, you do not ignore the minus. The minus is distinctively minus, distinctively negative, to not be positive. And so it's as if I'd created a series of numbers called times 1, times 1, times 2, times 3. And those were real numbers as well. They should be, by all accounts. And some people are going to try to do it. That's a great idea, actually. We could divide 1, divide 2, divide. And so it seems as though in order to create negative numbers, we had to force the idea of negative. It didn't simply arise from a natural understanding of the world, from just looking around and seeing 1, then 1, then 1. We had to abstract upon the natural, I suppose, evident, let's call it, reality around us. I can lead on now to, for instance, imaginary numbers, to keep going with our example. Imaginary numbers are, for those of you who don't know, and I am not a master either, but I know some about imaginary numbers. It's the idea of the result of a square equaling to -1. That is I. That is your base imaginary number. An imaginary number is created from forcing a result of minus, of negative, into a result that, for all intents and purposes, should be positive, should remain positive. Mathematically, we are not led to create this imaginary number. I suppose this is why they called it an imaginary number. You had to take that conceptual leap in order to get there. And so all of the complex plane, which is the mixture of imaginary and real numbers, along two lines that are perpendicular to one another, on a graph, on a 2D graph that we're looking down on in 3 dimensions. I'm adding all this detail just to be rigorous, because that's what we're doing, right? This complex plane is not compatible like negative numbers, with existential reality. And I think I understand what the problem is. Now again, I want to extend humility here. I don't know enough to truly be like no one can ever be 100% certain of anything. You always have to have this sort of level of doubt. And I want to express this now, somewhat humbly, that I may have made a mistake. But just in case I haven't, here we go. I think the problem comes from the idea of set theory, which is the idea that math is sets of numbers that exist abstractly in some realm separate from us. You can have a set of all positive integers, for example, positive numbers that do not have a decimal point, they're not fractions. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Add 1 every single time. Using the expression all positive integers is incorrect. You don't know them. You haven't defined them. But yet, here we say it, all positive integers. Because we imagine that we keep doing it. But what is this action? This imagine that you keep doing it. Like the stone. Well, there's a stone, then there's another, then there's another. It's an operation. Imagine you do more. So imagine plus, and then what? Then imagine plus, then what? Then imagine plus. And you're doing it. Plus a term, plus a term, plus a term, plus a term, plus a term. And so as you keep going, you realize I'm the one making this set as we speak. So there is no all numbers. There is only the operation. And that's what I'd like to say. That I think the best way to understand mathematics is as a unit and an operation. And that's it. And that if you do that, you find that the constructions that you imagine, like minus, complex plane, all these things, become a sort of elastic ability for us to operate on mathematics, on terms, in various ways, to give us the flexibility to understand complex problems, complex geometric problems. That means real world problems, positive problems, in existence problems. To come to physics briefly, negative mass, that's nonsense. It can't exist. Because negative means not existing. It means endowing this mass with the ability to do something to positive stuff. But that means it exists. It's not negative. It's a thing that behaves differently. If there is such a thing as negative mass, that's what it is. It is a thing that behaves in an opposite, geometric way to the geometric mass we understand as mass. I think this is probably understood, but just in case, once more, I just want to share these ideas because it doesn't look like people are on board with them. In fact, I'd like to expand on this idea of the unit and the operation. People often ask the question, is math invented or discovered? And I'd like to add my little something to that question, my little answer to that question, is that I think it's both. Because when you think about it, you create a unit 1. From this unit 1, you can create any other unit. You can create 0.1. 0.1 you cannot create without 1. You cannot get around from creating the unit first before you create any other concept related to the unit. There is no other way but to create this unit, and from that, to operate on it, to create another unit. We can just call all these terms now because the unit is unique. And everything based on the unit is another unit that is related to the original unit, 1, in some way. That way is operated on by your desire to operate on it. And there are a certain amount of ways that you can do this. But apparently, you can keep doing this because there is no end, apparently, to the space that we live in, to the reality we observe. And so we can imagine adding units, subtracting units. It doesn't matter. You can keep doing it. If you can keep doing it, then it's like what you're doing is creating the math. And yet, it's the only way you can keep doing, which is like saying that it was already there. So math is created by you in the only way possible. And that's like saying it is both invented and discovered. My name is Kieranlecam, and I hope you enjoyed this video. I actually wanted to talk about other things. I wanted to talk about a video that I'd seen on a channel that I enjoy watching, Numberphile, about how if you add all positive integers together, you get to -1/12 somehow. And I wanted to talk about the idea that it was a bit silly that you keep building positive numbers and you get to a negative number. I wanted to talk about the idea that you hadn't finished your operation. You'd added terms together, an aggregation of units, and you hadn't finished your operation. You just assumed you kept going magically, and then you put an equal there, and you just ... equal. Oh, it's an operation, it works. I wanted to talk about how that made no sense. And I wanted to talk about infinite sets, because I think set theory is wrong, but perhaps some other time. I'm Kieran, and I'll see you some other time. Take care.
Damn!
What you guys don't know is that this camera is on a pole. It just falls over like this. This guy's crazy.